Thanks for inviting me to this. And I'm going to talk from quite a sort of high level about the energy transition challenge and some of the stuff from my book, my latest book, There's No Planet B. And I wrote that book because I've been working on the climate agenda for, I don't know, 15 years or so. And it was clear that if you want to, it become inescapably clear, I guess, that if you want to deal with climate, you actually have to see the climate challenge as part of something much bigger that's going on for humanity. So I'm just going to do a very quick look at that before we get into energy a little bit more, and again at quite a high level. So just as Ian said, I've written those 3 books. Just a quick bit of context. There's the building I work at, Lancaster University, and I run this business, Small World Consulting, and we're kind of working with all kinds of businesses, from investors to energy companies to breweries to food companies to tech giants to whatever. And it's very interesting how the kind of conversations that we're having and the work we're doing has changed. It was a little while ago, a few years ago, it was kind of, can you help us understand our carbon footprint and can you help us get it down a bit? And now it's much more, we get it, there's a environmental and climate crisis going on. We get it that this actually affects everything. It's a big systemic challenge. It affects everything about every organization. How can we respond in a much more holistic way? And that's actually, in the end, that's exactly the way that that our response has got to go. It's a very holistic thing affecting just about everything about humanity does life. So what is this bigger thing that that's even bigger than climate, that climate is a symptom of? And actually looking at energy is the easiest way of starting to understand that. So here's just a graph of global energy use. It's just a smooth curve for 1850 to 1950 because the data is not great, but better data for the last 50 years or so. And there it is going up and up and up in fact, in a steeper than exponential way. But over the last 50 years, it looks pretty well exponential, with an average growth rate of 2.4% a year. And if that rate continues, that's like a factor of 10 every century, or a double up roughly every 30 years. But we've been growing our energy supply for millennia. And as we grow our energy, we get to do all sorts of great things. And it's one way in which we get to create the lives we've got for ourselves, and it enables us to develop new technologies and all sorts of things. And it gives us many things to be grateful for. But it's also true to say that through our use of energy, we exert influence on this planet that we live on. And as we've increased our energy supply, so our influence has increased. And for millennia, that didn't matter. I know even over the last centuries, it didn't matter too much. But gradually, the balance of power between humans and the inherent resilience of the planet that we're on started to change. And really recently, it's completely flipped. So 100 years ago, we couldn't smash the whole planet up, even if we tried. And we did kind of try quite hard around that time. But about 50 years ago, we were at a point where it was pretty clear that if we did something obviously stupid, like have a big nuclear war, we could make the whole planet hostile for humans to live on. But now, moving on to today's date, we've reached a point where we don't have to be particularly stupid. We just have to not be careful enough. And we're finding that we are smashing the planet up. And climate is one symptom of that. But actually, there's a whole rack of interconnected challenges. Some of them are physical, and some of them are kind of socio-economic challenges that lie underneath that. And so, which is my book was trying to encapsulate all of that into one short book. And so that's the kind of that's the sort of very big picture on the challenge that we face. And one way of looking at it is, some people use this big word for it, we've entered the Anthropocene, this era by which I just use it very simply to mean the era in which we've stopped being a small planet, a small species running around on a big planet, and we've become a big species on a tiny fragile planet. And we've entered this Anthropocene for better or worse, for better and worse. And we need to adapt quite a lot about how we do life in order to thrive in this brand new context for humanity. And as I say, the challenge we face is very joined up. It's kind of it's a very multidisciplinary thing, and so it doesn't work to look at. In the end, it doesn't work to look at climate in isolation from any of the other elements of the physical challenges that we face, or any of the other elements of kind of some of the underlying challenges that are behind that are to do with economics and politics and how people live and so on. So I sometimes show this, sorry, I just got my slides out of order. So that one way of framing up the challenge is that, it looks likely that if we take strong action to transition into an anthropocene fit way of carrying ourselves as a species, then we could live better than ever. But it's looked pretty clear cut now that if we don't make that transition, it's going to be quite a dark place for humanity before too long. And we don't know the exact timescale, but it does look like a fairly short timescale for that. So we've had a few decades of being in this Anthropocene, but being able to get away with living as if we're not. And now, and I do mean right now, is a moment at which if we don't make that transition, it's pretty clear that the symptoms are going to start hitting us quite hard. And I think we're increasingly just beginning to see some of that coming through. So, here's the whole book in one slide. And I sometimes show that just because it's kind of, ideally you wouldn't read one page at a time. You just kind of absorb the whole lot in one go, because that's what we need in our heads. We need to carry around a whole picture of this multidisciplinary challenge in order to take effective action. And just since the book was called No Planet B, I'll just very quickly mention this, that, is there really no planet B? Because we have got some multi-billionaires talking as if there might be a planet B that we could move out to. And just to nail it on the head, if you look at the kinetic energy of a human being traveling at the speed it would take to reach the nearest planet that would be any good to live on, which is 4 light years away, it would take, you'd have to be traveling at 1/10 of the speed of light, even if you're prepared to put up with a 40-year journey. And the kinetic energy of somebody traveling at that person, just the person at that speed, just the person without the spaceship, is something like the same amount of energy that 500,000 typical average humans get through in a year. So that's 500,000 people's worth of annual energy for one person traveling at that speed, just in their underwear without a spaceship. So it's completely unfeasible that in the next few generations, we could be doing anything other than living on this wonderful planet A of ours. Okay, so just to look at this, this multidisciplinary challenge that I've talked about, there's climate, and related to that, energy, of course, and related to that, transitioning our transport. Biodiversity is just as serious as climate, but doesn't get as much airtime. And of course, related to that is the food, is the food challenge of feeding better than ever a growing population, which brings in the population dimension to it all. We've got plastics and other pollutants, meanwhile, and ocean acidification. And of course, we've all been hearing about various disease threats. So all of that needs dealing with at once. Those are the kind of technical challenges, and they're quite complex to deal with. But the one-liner on it is that the good news is that technology turns out not really to be the bottleneck. We actually, by and large, have the solutions, but we'll talk a bit more about that in a second when we look at energy and climate a bit more. So what will it take for humans to be dealing with these technically solvable problems? Well, that takes us into questions of politics, economics, the whole notion of what it is to be in business, which needs to change a bit if we're going to have businesses that enable humans to thrive in this new context of the Anthropocene. It's unsurprising that an economic framework that was developed in an era where humans could expand and the planet was robust to everything we could do with it, turns out to need at least a bit of tweaking in order to still be fit for purpose in the Anthropocene. And technology is a really interesting one because, and we're working with tech giants as well as technology R&D institutions and so on, who are getting this message that actually technology has brought us many, many wonderful things, and we need some new technologies like crazy to get us through the situation that we're in at the moment. But it's also true to say that technology has taken us to quite a dangerous position at the moment, a very dangerous position at the moment. So somehow we need to renegotiate our relationship with technology so that we become better at selecting the ones that are good for people and planet, and much better at leaving on the shelf technologies that might not be in the best interests of people and planet, even if they offer us an efficiency improvement. So there's a kind of whole new agency over the trajectory of technology that we somehow need to get our heads around. Politics, we're going to be hearing all about over the next few months with the COP especially. But the challenge of at the end of the day, somehow we need to deal with these global crises, these global challenges at a global level. And that's going to involve some level of global cooperation on a scale we've never had to have before. Related to that, questions of inequality, and I talk about this a lot in the book. There are questions of kind of media and truth and trust that we need to get much better at valuing and being able to see the difference between fact and fiction. And I do think that's got implications for everyone who's conducting themselves in business. Okay, and then, but right at the center, you see I've left us a space in the center of this slide for what's possibly right at the heart of it, which are questions about, actually human values and how we think. And it's amazing how many scientists have come to sort of similar conclusions to me about this, that maybe it all, at the end of the day, it all boils down to some very simple values that we either can cultivate at the global level as cultural widespread values, which will enable us to get on well together and live nicely on this fragile planet of ours, or we won't succeed, in which case almost nothing we can do will help us. Okay, so that's some big picture about the whole challenge and where energy and climate fits, because I think when we're trying to deal with energy and climate, it's important to keep it in a wider in its context as part of a wider framework of a bigger and richer multidisciplinary challenge. Okay, on to have a very sort of high level look at energy and climate. So here's my one slide, which I'll build up on the climate emergency. So to start off with, here is a graph of global CO2 emissions just over the last 60 years, and you can see it's going up and up. And the big thing to notice about this is that there is no statistically significant evidence that from this curve that humans have noticed climate change yet. So if you were looking from Mars, looking down on humanity at our carbon emissions curve, actually you can do this over 160 years or something, you'd actually see a pretty mathematically exponential curve. And you would notice a few blips in that, especially for world wars, oil crises, and economic downturn. And you would also notice that after those temporary downturns, you'd see the energy curve going above the exponential trend line again. So it kind of oscillates a little bit. But so you'd see that, and you'd notice a little dip over the last year or two for the pandemic, from which it looks as if we're bouncing back up again. So you'd notice that humans have one or two incidents go on in their history. But if you were on Mars looking at humanity, you probably conclude that humans hadn't yet spotted that climate change might be an issue. And I'm not saying this to be depressing, but I am saying it because it highlights something about the nature of the challenge that we're facing. Climate change is a global phenomenon. And at the end of the day, one way or another, we need to have a global solution to it, which doesn't mean to say that it isn't incredibly helpful or essential even for individual people and companies and countries to be doing their thing. It absolutely is, and it builds up the conditions under which we can get that global change. But until we can get it somehow going on at a global level, actually, it looks like the sum of the parts is the total change we get is less than the sum of the individual parts. So why is that, when we all know of people, countries, and organizations that are trying to do their bit? And it's because the system, at the global level, the system dynamics of it all, it turns out to be a bit like squeezing a balloon. So if you squeeze the balloon in only some parts, there's a nasty tendency for the other parts of the balloon to expand, to take up the slack. And that's why we're not yet seeing any dent at all. It doesn't mean to say we can't make that dent, but it does mean to say we need to A, raise our game, and B, we need to find a way of exerting our influence so that somehow it becomes a whole global thing. Okay, this little bar chart is one actually from a previous book years ago. It just shows the total fossil fuel resources, that's defined as fossil fuel that's in the ground that we know how to extract, though not necessarily profitably at today's prices, compared to on the double coin flip on the right hand side is the amount that we could extract to stand a 75% chance of staying within a 2-degree temperature rise. And to be very clear, the IPCC is very clear that 2 degrees is a really dangerous level of temperature rise. So we absolutely have to leave the vast majority of the fossil fuel in the ground. And in fact, the carbon budget we've got left is really quite small and shrinking significantly year by year. Okay, which takes us on to the kind of final big thing about the climate challenge, which is the really interesting part of the phenomenon, which has been how slow we've been to wake up to this, because it's been as clear as daylight for decades. But just to be optimistic, the good news is that head that's in the sand there, I think over the last 2 or 3 years, the evidence that that head is really trying to pull itself out of the sand is far stronger than it's ever been. So the question is, can it get out of the sand in time? Can we do the big wake up? And the answer to that is, I don't know, but it looks more hopeful to me than it used to look. And it would certainly seem to be the case that the harder we pull, the better the chances are of getting it out. And maybe it's moved the first millimeter, and maybe the first millimeter is the hardest one. Okay. I said that energy was going up at 2.4% per year. And this slide, I think, is a really important concept for us all to get our heads around, which is that we can have all the renewable energy that we like, and it won't do us any good at all if it's just in addition to the fossil fuel that we're currently extracting. So at the moment, it looks like, and I'll talk about this coming up, it looks like it's perfectly possible for the world to transition its current energy supply to a clean energy supply in a timely manner. There's all kinds of challenges on the way, but it's a perfectly doable thing. But the problem is that supposing we were to do that by 2050, it would do us no good whatsoever if by 2050 our total global energy use had continued to rise at 2.4% per year, because by that time we would have doubled our energy demand and we would still be needing all the fossil fuel that we're currently extracting. So life gets a lot easier if we can actually come off that rising energy use trajectory that we're currently on. The good news is that because we've got efficiency improvements coming out of every industry and every technology you can think of, it still enables us to grow in all kinds of ways if we want to, and we can still live better than ever. In fact, we can live better than ever with a decreasing energy demand if we put our minds to it. But let's just say that the lower our energy demand, the easier the energy transition becomes by a lot. And that principle applies at every level, and definitely at the island level. Okay, and then just a quick overview of global energy use at the moment. So primary energy use. So the vast majority oil, natural gas and coal. But you can see that I'm including in my definition of primary energy use here, I'm actually including, it's not often in the statistics, but I'm including the food that we eat, the kind of most traditional form of energy that humans have got. And it's still, I find this kind of reassuring, it's still 5% of the total. And then 6.9% wood, and then all the slivers in green, blue, and nuclear, which I know is contentious with some, but it's those three slivers really, the green, the blue, and the purple, that need to, in record time, expand to replace the coal, oil, and natural gas. And they need to do that in a way which, without just supplementing them, they need to actually replace them. Okay, now it's high time for some good news. This dot, the black dot there, is to scale, and it's represents a piece of land that, if it was square, would be 228 miles by 228 miles. And if you put solar panels on that land, you could generate enough energy, the same amount of energy as the total human primary energy demand globally. And it turns out that actually that's, broadly speaking, doable. There's no big crunch. I mean, it's difficult to make the solar panels, but it's doable. So solar is the big source at the global level. Solar is the big source of clean primary energy. But just to re-emphasize the point about energy growth, if we stay on our energy trajectory, it looks like one dot now. In 100 years' time, it would look like 10 dots. In 200 years' time, it looks like 100 dots. And in 300 years' time, we'd need the whole of the world's surface area to be totally covered in solar panels, leaving no space whatsoever for a human on land to have sunlight landing directly on their skin, because they'd be casting a shadow on a solar panel, and we'd need the energy from that solar panel to meet our energy demand. So at some point, we need to come off this rising energy, this trajectory of rising energy demand. Now, of course, I've made it really simplistic, just saying, well, let's just put up the solar panels. And it's not as simple as that, because there are times when the sun isn't shining, and there are places that don't have the sunshine, and there are even some forms of energy use that we have at the moment where electricity isn't the form that we need it to be in. So so all kinds of other difficulties that we need to overcome. But broadly speaking, the big primary energy supply in the future for the world is going to be mainly solar. So one of the questions is who gets the sunlight? And this is going to be really important, especially when we're trying to find a global arrangement that everyone can live with for a clean energy transition. And so this map it's a squidgy map, so it's to scale with the sunlight. And the color coding represents the sunlight per person. So you can see Australia looking really dark there because it's got a lot of sun per person. In fact, it's got 200 times the sunlight per person that we've got in the UK. The UK turns out to be the 5th worst country in the world in terms of sunlight per person. I'm only counting countries of reasonable size in this. So I'm not counting, I think I discounted Luxembourg, for example, from this. But we're just ahead of, the UK is just ahead of Bangladesh, Rwanda, the Netherlands and Belgium, but it's in fifth worst place. And Ireland has got about 4 times as much sunlight per person as the UK. So in the UK, solar has a role, but we're very unlike Australia in that it can't be the big dominant. It can't be the single big dominant source of energy. So we need to have, luckily, we've got other sources like wind and a little bit of tidal and a little bit of hydro and so on, but we've got really good offshore wind. If you look at Ireland then, this map doesn't show it too well, but you can see Ireland looking a bit better on the sunlight. So it looks like sunlight would be a bigger primary source of energy for you, more significant than for the UK. Just a quick look at the global perspective. You know, one of the things with this energy transition, it's going to have very different implications for different countries. So I've just racked up here the top countries in the world in terms of their total fossil fuel reserves, including coal, oil, and gas, and lined that up with the proportion of the sun's energy that lands on their land mass. And you can see, broadly speaking, that the countries with the most fossil fuel also have the most sunlight. And that's not totally a coincidence if you think about how fossil fuel is formed in the first place. But there are 1 or 2 countries that end up with what looks at face value like quite a difficult situation coming out of this. You know, Qatar and Germany in particular kind of stand out from this graph. Okay, so let's have a look at the wind. And you can see, in fact, Ireland doesn't show up too well in this map. I'm not quite sure why that is, but you can see that if you look at an analysis of who has the most wind energy, this is a pretty crude analysis, but it's showing that the UK is looking at least a bit larger and a bit darker. So it's kind of more encouraging we have a better wind at least compared to our sun, where we stand in the sunlight rankings. And I would guess a similar situation for Ireland. Just want to talk just quickly about the role of hydrogen in all this, because I've talked about how it's fantastic we've got this sunlight and backed up by wind, and those are the two primary sources of energy, and then some other bits and bobs, a smattering of other bits and bobs. But the problem with all of that is that a lot of this energy turns out to be in the wrong part of the world and at the wrong time for when we want to use it, and sometimes not in the form that we need it to be in. And it turns out that hydrogen actually can be massive in solving all of those problems. So going into the future, hydrogen's going to have a huge role. I think that's pretty clear cut. So first of all, for energy storage, so taking electricity that's generated at times when supply is higher than demand, and using it to through electrolysis, turning it into hydrogen, and then we can store it somehow. And there's discussions and debates about the best ways of storing it. It's probably a mixture of different ways, but big underground storage, or is it best to compress it to, let's say, up to 700 bar, or is it best to transform it into ammonia, which is a bit toxic, but is a much more compact form of storage. So there are various storage solutions. Energy transmission and questions about different ways of storing it, whether to put it through pipes, whether to compress it and put it onto ships, which means a complete re-engineering of ships because the density is so low and the volume is so high, or whether to liquefy it, which means taking it down to minus 250 degrees centigrade, or whether to turn it into ammonia actually as well as a way of shipping it around. But anyway, it turns out to be possible to store it, possible to transmit it over long distances, and then energy distribution, by which I mean the shorter distances, which again, questions about whether to do it by pipes or by compressing it or whatever, but various ways of distributing it. And then ways in which we can use it for our final energy demand. So it's going to have a central role in transitioning steel making away from using coking coal, and that's pretty well ready to go. It's pretty clear cut. It's got a big role in transport, especially heavy transport, heavy road transport, where batteries are going to be a real crunch point. And in fact, it looks like batteries and the grid, and there are all kinds of problems with totally electrifying road transport. And even I think questions about whether or not there might be quite a big role for hydrogen in lighter road transport, right down to personal cars. Sea transport, definitely, other industry. Air transport, although there's a huge load of re-engineering of our aircraft to be done on that, and we need to get moving on that quick. Questions about how we heat buildings, and hydrogen has a role here. Either we turn it back into electricity and heat our homes electrically, allowing us to use things like heat pumps and so on, or we pump hydrogen through the gas. And that's kind of one of the battlegrounds over where hydrogen is going to be. But so there's a quick sort of sketch on just how central hydrogen is going to be in the future. So just quick summary, we need to both leave the fossil fuels in the ground and grow our clean energy supply to replace it, not just one of those two things. In the end, it needs to be at a global level. The more we limit our energy demand, the easier that transition will become. Efficiency on its own has a weird dynamic, actually. I meant to talk about this more as we went. The default role of an efficiency improvement is that it ends up leading to, very often, usually, ends up leading to a net increase in total demand for resources and for energy. The dynamics of that are quite complex, but Stanley Jevons noted it 150 years ago or so when he looked at the UK coal industry and realized that actually if we got more efficient with our coal use, you know what, that would lead to an increase in demand for coal, not a decrease. And we see that phenomenon right across the board in all sorts of things, not just energy and not just carbon emissions. But it doesn't mean efficiency improvements are bad, but it does mean that they won't on their own solve the problem. They need to go alongside a cap in total emissions that needs to be kind of separately implemented. So the clean primary energy is going to be, solar's the big thing, wind is going to be the big backup, and then there's a whole range of other bits and bobs. But for the UK and probably for Ireland, solar somewhat less dominant than the size of the fonts I've shown in there. Hydrogen's going to have a massive role. We are also going to have to remove carbon from the air as best we can through nature-based solutions and through direct air capture, carbon capture and storage, both of which are fundamentally limited solutions. So they are not things that we can do instead of curtailing our fossil fuel use. They are things that, because we've allowed an emergency to develop to such an extent, we need to do as well as. And at the global level, the question of how we share the remaining fossil fuel budget and the clean energy capacity is going to be really critical. And I think that's going to be the big question that's going to be playing out in the COP. And then one very quick look at primary energy in Ireland. I'm conscious I'm out of time. I'm not an island energy specialist, but some good things to note here is that the long-term trend on your energy supply, total energy demand, is not going up for the last 30 years or something, and that's encouraging. That's something that needs to be maintained. And one other encouraging thing is, of course, that the coal's going down and the renewables are going up, and both those two trends need to, of course, increase in speed. I know there are people with a lot closer to the island energy market than me going to be talking shortly. So, as to summarize, I'm out of time, so I'm going to just very quickly whiz through a couple of things on the stuff towards the center of this graph. I'll skip that one, but just to say, I think, probably 3 values that we need to cultivate at a global level, if any of this is going to come together, is respect for all people all over the world, by all people. We need to think of ourselves as a global tribe now, like it or not, because we're one species on this planet together. We sink or swim together. We need to extend that respect to the rest of the natural environment, and we need to start respecting truth in a way that we aren't yet good enough at. And I think all those who are kind of commenting on the energy market and the energy transition need to be really, this is really critical in this area as well. Just to be, you know, when we hear misinformation, and I think there is misinformation that comes around from time to time, I think it's really, really important to challenge it very clearly. So truth and trust, we need to ask very carefully, much more carefully, who do we trust and what's our basis for trust? If we get this right, we can have a better world. This is my one slide to try and describe it. We could all describe it differently. We need to spend more time describing that kind of thing. And but it really is a race between tipping points. You know, on the one hand, I think we've got energy, we've got evidence that the world is beginning to wake up. On the other hand, the symptoms are beginning to hit us. If we're not feeling some adrenaline, we really should be. And I'll stop there. Thank you for listening.
That was really interesting. And it was great, particularly the pictures at the end of what we might look like we become in the. I don't know where those pictures are from, but it kind of looked like Germany in a few of them. So you know, maybe a couple of countries are ahead. I just to the audience members, just to let you know, the Q&A function is open if you'd like to ask any questions. But I've a couple that I wouldn't mind just talking through with you, Mike. My own personal view is that until now, there's the public and society have played a lot of lip service to climate change and changing behaviours, and then actually when governments and policy, you know, are introduced, which are intended to change behaviours, you know, there's a huge amount of backlash. You know, we've you know, carbon taxes and those kind of things are being introduced by budgets, and they're tolerable, but only at very, very low levels. So, I mean, I think we're moving into what you might call a great discomfort period for people in society, in that in order to arrest the increase in carbon emissions, that people's behaviours are going to be changed to such a degree that, you know, they will be moved out of their comfort zone. But do you think societal buy-in to these solutions is an essential element of that possible global cooperation? Because, you know, states are great at making deals and agreeing commitments around delivering on X, Y, and Z reduction, but unless they have society along with them, it just won't happen.
Yeah, I think that's right. I think it all comes together at once. You know, states can't do it without the people. Business also has a huge role in all of this. I think, you know, it'll all come together at once. I think it's clear that those three different actors, individuals, the public, businesses, and the state, you know, influence each other. So, for example, in the UK, when the kids took to the streets and Extinction Rebellion took to the streets a couple of years ago, you know, and at their best, they were pretty, you know, I think they were very effective. You know, that helped the government, UK government, to get the confidence to crank up its carbon targets. Around that time, I was also feeling a real change in the mood from the business community. The kinds of inquiries we were getting just changed in nature. People were, you know, a lot more serious, a lot more ready to go out to brands, much more ready to go out to their public, saying, look, we really get it, there's a crisis going on. And even investment asset managers coming to us saying, we want to look much more carefully at what's in our portfolios. So I think it all comes together at once. And I do feel the beginnings of some change. And I think it might be a very short time before there's a lot of change. You know, it's undoubtedly a different environment. When brands are asking, you know, how will this go down with the public? You know, it's a very different kind of equation from what it was 2 years ago, I think.
Yeah, and the ESG driver has been phenomenal, and we've seen that having an impact on asset prices for renewable infrastructure, certainly in Ireland, and I think globally it's just had a massive impact. And just on that, I mean, do you think sustained economic growth and effective climate transition I mean, is it a paradox? Can it be achieved?
It's a really interesting question, the whole growth question, because, and I think it gets framed up in the wrong way. Like, sometimes is growth good or bad? And I'd like to talk about what types of growth. So it's clearly we can't keep growing our carbon emissions. Can we keep growing our energy supply? That looks dangerous to me, and it looks like it makes things more difficult for us. Can we aspire to grow human well-being? Yes. Can we aspire to grow our biodiversity? Yes. Can we grow GDP? I kind of think, actually the answer to that is almost who cares? I don't have a problem with the idea of GDP growing up, but it's going up, but it's fundamentally the wrong metric to be chasing. We do need to find metrics that are much more closely aligned to the well-being of people and planet.
Yeah. And actually another question there sort of on a related point is around your comments around energy consumption reduction and efficiency. And I mean, do you think sufficient emphasis has been placed on reducing that demand? I suppose the more exciting things for government to talk about are new developments, new infrastructure, but and they talk about there's a lot of money that get put into retrofitting, which is, I suppose, is good, but that's consuming energy even just through its installation in the short term.
Yeah, I mean, retrofitting is worth it though. The energy you consume in doing the retrofit pays itself back. So it is, it is a way in which we get to be able to live well for less energy consumption in the future. That's a good thing. I think that the critical thing is that efficiency improvements only bring down carbon, don't on their own bring down carbon emissions. What they do is they allow us to live well in a world in which we've already taken the steps to make sure the carbon emissions go down. So it's sort of, the fact that we can implement those efficiency improvements gives us confidence that we don't need to suffer at all in capping the carbon. But we do need to cap that carbon in order to deal with climate change. And then when we've done that, we will value efficiency improvements more than we've ever valued them before.
And how about things like reducing air travel? Is that a realistic goal to be achieved?
Well, come the day when we've got a global carbon cap, or we've got a global carbon price or some mechanism that restricts fossil fuel use, it'll be up to us how we share around the remaining budget. But I don't think overall dealing with climate change is wearing a hair shirt, but I do think there are some, along the way, there are some areas where there's a crunch point. And air travel has to be one of those things. There's hard realities. We don't know how to put planes in the air properly yet without going through a lot of fossil fuel. And we are going to need to be somewhat more careful about when we fly, which doesn't mean no flying, but it probably means, those people who take a lot of weekend trips to New York, weekend shopping trips to New York, probably need to not do those anymore and keep it to, one a year or something. It's not about nothing. It is about some constraint.
And just one final question is just around how can individual businesses predict business valuations in such a rapidly changing world?
Well, that's interesting. So one thing to do is to have a look at your carbon emissions, and I don't mean just your operational emissions. You must include the entirety of your supply chain in that. And if you take that number that you get, your carbon footprint, I'll call it, and you multiply that by what you think a carbon price might become, then that's going to be the cost you're going to face. And if that's more than your competitors, then you're disadvantaged. And if it's less than your competitors, then the low carbon transition is going to be a net opportunity for you. And if you can sort your supply chains out in advance now, then you're making good headway. I mean, I think the message I'd give to all businesses is to say, you've either got to say the world is not going to get on top of climate, in which case you should be planning for humanity to enter quite a dark place quite soon. Or you say, we'll wake up and we'll get on the case, right? In which case, all the businesses that have sorted themselves out ahead of time, sorted out their supply chains as best they can, moved into all the technology areas that we're going to need like crazy in order to make that transition, you will be absolutely cashing in.
Well, on that positive note, then we might move on to the next panel. So thank you very much, Mike,